Good afternoon, everybody. We are still on Linux. In the last session, we were able to start with some commands. But before we proceed today, we want to look at how we can set up an instance and proceed to logging into MobileXterm, right? Although we've done this before, but we just want to go through it again just for further clarification, okay? We have a server setup, okay? So if we come here, we'll see our AWS account, which we've created together, okay? Now that we have an AWS account, we can log into our AWS account. This is a user, this is the ID, and this is a password. Okay. So now that we are in our AWS account, to access EC2, right? Elastic Compute Cloud, that is Elastic Computer in the cloud, right? So we click on this EC2, okay? And it shows us that we have one instance, okay? Let us assume we do not have an instance set up, okay? Or we want another instance. This is the instance we have set up and we've installed all of those things in, okay? But let's say we are doing this for the first time, okay? We have MobileXterm quite all right. And MobileXterm will trigger us to enter our remote host, which is the IP address, okay? But let's say we do not have an instance created before. This is something we'll do, especially as we'll be looking at different tools as we proceed with this program. Okay, we can click on here to launch instance. Okay, then this environment comes up. Okay, now I can call this instance whatever I like to call it. I can say Linux instance, right? I can call it this. I can call it Linux instance. I can put underscore in between, right? Linux instance to make it easily readable, right? Then I scroll down a bit, right? And take a look at here, number of instances, we have one, right? What this means is that you could create multiple instances. You could create 5 instances, 100 instances at once, okay? Just for the purpose of this, we are just creating one instance. So we'll leave this as one. We scroll down gently, right? So let's say we want, remember we talked about different Linux distributions. So Red Hat is a distribution, Ubuntu is a distribution, Amazon Linux is a distribution, whereas Mac OS is an operating system that is not a Linux distribution. You also have Windows as an operating system that is also not a Linux distribution, okay? You can see SUSE Linux, you can see Debian, right? All of these distributions were the distributions we looked at when we were looking at the different available distributions, right? So now, let's say we want this distribution, right? We want an EC2 instance, right? An elastic computer in the cloud, a remote computer somewhere in Ohio. This one I'm booking is somewhere in Ohio. That's where the data center is, right? AWS data center. So I want a particular distribution, and the distribution I want is the Red Hat distribution. So I select this, okay? Now, under here, I see free tier eligible. I like the sound of free, right? So we'll go with that, okay? Then we scroll down, I still see free tier eligible. Remember, we talked about free tier eligibility, right? So if you have free tier eligible here, you need to stay on this, right? Because T2.micro will serve the purpose we want, right? With running our commands, right? But as we proceed with this program, we'll see that T2.micro will not suit some other tools, okay? But for now, T2.micro, we'll leave it as it is. If we're changing, we would have had to click on the drop down to select something else, but we'll leave it at this. Now, key pair login, okay? Key pair is the key you need to get access to that remote computer somewhere in Ohio, right? But if you look at here, I already have a key pair. But if I do not have a key pair, if you click on this drop down, you see the key pair, right? But if I do not have a key pair, I can create a new key pair by clicking on this, okay? So if I click on this, it tells me to enter the key pair name. I'll set up a name, okay? Then I leave this as RSA, I leave it as .pem. So when I'm setting up a name, I can call it whatever, but I don't put .pem, right? I won't put .pem. This .pem extension comes with it by default. You can see .pem, okay? So I do not intend to create a new key pair, but if I'm creating a new key pair, all I need to do is to come here and click on create, okay? But I want the screen to be large, so that's why I'm reducing it, okay? Making it give us a maximum view, okay? So I do not intend to create a key pair, so I'm closing this, okay? So I've chosen February 2023 DevOps class as my key pair, right? Which is in my download folder. If I check my download folder, let's see my downloads. You see, I have it set up here, right? So it is right here, okay? So I can see it. If it's missing, it means you can't get access to using it. So you need to create a new one, okay? Just be sure that you have it, okay? So if you don't have it, you can create a new one, okay? So if you look at this now, you can see that we've set up a key, right? We specify the key we want to use. Then scroll gently. You see something here says allow SSH traffic from anywhere, right? You see this SSH traffic is that port 22, right? Take note, is that port 22. You see this port 22 is the SSH port, right? So if you mistakenly do not check this, right? Though it comes checked by default, but if you mistakenly uncheck it and you go ahead and launch an instance, you realize that you will not be able to connect, okay? Because you did not allow SSH traffic, okay? So I scroll down gently and click on launch instance. But if for some reason I do not allow SSH traffic, is that the end of the world? No, okay? We can always go to security group after creating the instance to add port 22 as security under a security group, as a port under the security group, okay? But we'll get to see how we do all of that as we proceed in the program. But right now, all we need to do is to click on launch instance, okay? So when you launch this instance, okay, you can see, can click on this, it shows it's a success, right? Then you can see it's pending at the moment, okay? I can click on this, you can see it's pending at the moment. So once you finish launching it, it's going to show success, right? It's going to show success. You can see it's running now, right? So once it is running, you'll be able to take further steps, okay? But I do not intend to keep this instance. I already have one I created. All I need to do is to start that instance, right? You can see there are different things you can do. I've checked this now, for example. You can come here after each day's work, right? You can stop the instance and start it whenever you want to start it again, right? This is an option. You can stop an instance, okay? That's an option. Another option is you can reboot an instance in case you feel it's not connecting and everything is working. Sometimes the system just requires a boot, okay? Or you can terminate because I do not actually need this instance, okay? So I have an instance that I already stopped. So I just need to start that and get it running. So let me terminate this. So with this, we've seen how we can launch an instance, okay? So now that we've launched an instance, the next thing we want to do is to go to the other instance that we have, right? This other instance that we've been working with, that we've stopped. So we want to click on this drop down. So you see options. Because it was stopped, you can see options that we have include start and terminate. When it wasn't stopped, we saw option to stop and to reboot, also to terminate, right? But now we have option to start. So I want to start it. I click on start. So you see successfully started. Then if I refresh this, you will see that it's in pending state, whereas this has been terminated. After a while, it will disappear, but for some time, it will still show up as terminated. Okay, so I click on this, you see, I have a public IP address. There's something we should note. Anytime you stop and start your server, this public IP address changes. We'll get to understand why as we proceed in this program. But the private IP address never changes. It remains as it is, right? But the public IP address will keep changing, okay? So I have my public IP address, right? You see, instance type t2.micro. Now, going back to what we talked about, security group. Remember, we talked about security group. If we need to change it in case we didn't specify it, you can always click on this, but we'll get to see this as we proceed in the program. But let's keep it simple for now. So all we need here to connect is the public IP address. Why are we not using the private IP address? The reason why we are not able to use the private IP address is that wherever you are, right, you have an IP address, right? And the IP address is provided by the internet service provider. See, I open a new tab. I come here, I type, what is my IP address? Okay, see, this is my public IP address. This public IP address is for my location, where I am here in Canada. This is my public IP address provided to me for this address I am in based on what the internet service provider has provided. This is my public IP address. This will change anytime I restart my router, right? My internet router. When I restart it, another public IP address will be generated. But for as long as it remains on, this will be my public IP address. So if I decide to check on my phone right now, I'll realize that the public IP address is still the same as what is displayed because I'm on the same network. Okay, you can see I'm on the same network. So when you look at here, right, you see an IP address was generated. Okay, you can see this instance. This IP address was generated. So if I decide to say, okay, I want to stop this server, you can see what the IP address is right now, right? If I stop this server, let's stop it, right? I've stopped it. You see what it is right now, right? I see the private IP address is ending in 225. I see what the public is. I've stopped this. Let me refresh it. Okay. You see that when you see the public IP address is gone, but the private IP address remains. Okay. So if you come here and start, right, and give it a while, you see that a different IP address, right, will be generated, which is the public IP. It's not generated yet. Let's see what we had there before. Let me paste it. I think I copied it. This is what we had there before. You can see. Okay, that's what we had there before. So let's refresh this to see whether it will come up. Previous one ends in 131. I copied it. So it has not generated yet. Okay. All right, so let's give it some time to generate. It's still starting up. You can see the status is showing pending. You can see the status has changed to running. You can see we now have a new IP address. See, compared to what we had before. See, this is what we had before compared to what we have now. Okay. So if we pick this one, right, and we come here and say, we want to connect, right? This is the previous one. Remember the previous public IP address. I come here, I specify username, EC2-user, right? And I say, oh, port 22, which is the SSH port. Okay. I click on advanced. I click on private key to pick up my key. Okay. This is my key, February 2023 DevOps class. And I click on OK. It will not connect me because that public IP address I'm trying to connect to does not exist. You can see it's taking time. It's trying hard. You can see it's really trying hard to connect. But along the line, it's going to fail. Okay. So, but while we are waiting for it to fail, let's start a new session. Okay. Let's start a new. You can see network error, connection timed out. We couldn't connect. But let's start a new one using the new public IP address. Okay. So we have a new public IP address. We've copied that. Copy it and paste in here. Okay. Specify username, EC2-user. Okay. Port 22 is open. Advanced SSH settings. Okay. So we come here and click on use private key. Then we select the key. Okay. So once we do this and click on OK, we are in. Okay. So you can see we are in. We use our first command here, clear command, to clear the screen. Okay. Control plus to enlarge the screen. Okay. So we can see it from wherever we are watching. Okay. That's control plus. Okay. Depending on how enlarged we want it to be. So now that we've done this, remember, we've looked at some commands in the past. So we want to continue with our Linux commands, okay? In the last session, we looked at directories, navigation commands, right? We created directories, we checked out the lists we could have, right? So today we want to look at file maintenance commands, okay? File maintenance commands, okay? So there are some file maintenance commands. Remember the last time we created directories, remember? And we talked about directories being equivalent of folders, right? If you look at here, this is a folder, right? Containing all sorts. These are folders, right? You can see folders. And this is a file, right? This .pem is a file, logo, you can see file, folder, yeah, you see. So what we've dealt with was directory, right? Directory relates to folders, right? Directories are the equivalent of folders when we are looking at Linux, okay? So now let's look at how we can create directories on the command line using the mkdir command. But today we want to look at file maintenance commands, okay? File maintenance commands. So if we do our tree, let's see what we have here. Okay, we only have one directory left because we've deleted the others. We wanted to show that we knew how we could delete directories, right? And we've been able to also delete directories, right? So now we want to look at file maintenance commands, okay? Want to maintain files, right? So for example, you can say you want to create a text file, right? You can say you want to create a text file, you want to create a Python file, right? You want to create a YAML file, right? If you remember, if you look at these files that I have created here, right? You can see these are YAML files, okay? We'll get to see how this works, okay? So I can come here. This is not Linux, right? This is VS Code, right? We talked about integrated development environment. We'll get to see how all of this work, right? As we proceed in this program. Okay, so now we want to see how we can create files, okay? If I was here in my downloads and I want to create a file, I can right click, I can say new, I can say, oh, I want to create a folder, I want to create a text document, I want to, depending on what I want to create. this is how I do it on Windows, right? Depending, okay, this is how I do it. But on Linux, how do I do it? Since Linux is what we are concerned about now, we want to look at how we can create files in Linux, okay? So in Linux, you need to use a command called touch. You touch a file, okay? You touch, okay? So what's the file name I want to call this file? Okay, let's say I want to call this file linux.yaml, right? You can see this is a file extension. I can also say linux.txt, text, right? I can say linux.xlx, right? Excel, right? I can say linux.py, Python, this Python extension, right? I can say linux.java, Java extension, right? So whatever it is I want to say, right? And I can even create a file without putting an extension, right? But best practice, create a file and put an extension, txt. Let's say I want to create a file and call it linux.txt, okay? So if I do this, this file has been created. But how do I verify that? Let's see, tree command. You see, we have linux.txt. So this is a file, right? We've created this file. So how do we see the content of a file? Right now, this file does not have any content because it's an empty file we created. We just created this file by running linux.txt, right? So let's say we want to check the content of the file, right? Which we know is empty. We use cat command, cat. Use cat to check the content of a file, right? Cat, right? Then you specify the file name. If I enter this, you see it's returning nothing, okay? So this is returning nothing because there's no content in that file. But how do we put a content in a file? If you recall, in the previous sessions, we looked at text editors, right? We looked at text editors. We talked about VI, we talked about Vim, we talked about Nano, that all of these text editors can be used for Linux, right? Vim, VI, and Nano. So this VI typically comes by default with Linux. When you install a Linux server, you see this coming by default with it, okay? So let's see what happens. To put in a content in a file, let's say we have some content. Yeah, it's good that we have some content here. Let's say we want to copy all of this content. You see, I've copied the content here, right? Let's say I want to put this content of this file in here, right? I can say VI. Remember, we said there are three editors. There's VI, there's Vim, there's Nano, right? There's VI, there's Vim, there's Nano, okay? So I can VI into this file. So to VI into this file, I can say linux.txt. Say VI linux.txt because I want to put some content in that file, right? So if I say VI linux.txt, I say enter, it opens up the file, right? It opens up the file. And when this file is open, what we can do is to enter hi to insert, okay? We won't go into details of this right now, but I just want to show us a simple way, okay? Because we'll still look at text editors in details as we'll be using it as time goes on. And I'll make sure I echo whatever command so that it sticks, okay? So I to insert, then I've copied something, I want to paste it in here, okay? Can see the content I've copied, I've pasted it here. Then I click on escape, column WQ. You can decide not to focus on this for now, right? I just want to show us something. So you see how cat command works, okay? So remember, the last time when we checked the cat command, okay, this cat command, when we checked it earlier, it returned blank, right? But now we've put in some components in that file, right? The file is no longer empty. So if you cut that file now, you can see it displays the content of the file, right? You can see these are those things that you have in the file, right? So it's displaying the content of the file. You can see when you cut now, it's displaying the content of the file. Okay, so now the content of the file is displayed. Okay, so looking at this, right? Looking at this, you can see that we can use cat to display the content of the file. We use touch, right, to create a file, to create a new file, right? Then you can now use cat to display the content of the file. Just as we can use touch to create a file, there's yet another way we can also create a file, okay? There's yet another way we can create a file, okay? So let's see the other ways of creating a file, okay? Let's say the next file we want to create now, let's call it intro file, right? Let's say, or list file, right? And say, instead of specifying touch before the file name, you can just use either VI or Vim, right? But if I want to use Vim, because Vim requires installation, I need to install Vim, right? If I try to use Vim, I'll see that I'm going to encounter like an error, right? If I try to use Vim, okay? So to use Vim, you need to install it, okay? So I can either say VI, then say list.txt, right? I want to create a file called list, okay? List.txt. If I do vi list.txt, it's going to create a file, right? And open straight. It's like doing two things simultaneously. It's creating a file called list.txt, and it is also giving me the opportunity to put something in it, okay? So I can list some names, okay? Let's list some names here. I to insert, press I to insert, okay? Then you start listing. Ade, Mola, right? Ola, right? Ed, Ensure, right? So we have 5 names, right? So if you want to save the file, click on Escape, colon, that shows at the bottom, WQ, okay? So this saves the file. So if you want to check the content of the file again, you can do cat list.txt, cat list.txt, right? You can see we have the content of the file displayed. So we've seen how we can also work with files, right? These are file maintenance commands, okay? So other than this, okay, it is also possible that we might be looking for a certain file somewhere, right? Might be looking for a certain file, right? We'll say, oh, there's a file we are looking for. Where could this file be, right? Right now, we are here in the home of the user, but it's possible that we are looking for a file somewhere else, right? We can say we are looking for a file right here, okay, where we have multiple files, right? So there are different ways of looking for a file. And what do you think the command for looking for a file would be? It is as simple as it gets. And that command is called the find command. You can use the find command to look for a file, right? You can use a find command to look for a file, and not just files. You can also use it to look for directories, okay? You can use find command to look for files, you can look find command to look for directories. Okay, so let's see some options of how we can use the find command. Okay, let's look at some options of how we can use the find command. Okay, so to use the find command, you use the, depending on where you are searching. Okay, let's say, let's clear our screen. Okay, let's clear. Okay, find command, right? As the name suggests, find. Okay, see ls right now. You see we have this web class, Linux, txt. You see, you can see what we have here. Okay, so one thing we can do, okay, let's look at different ways of using the find command. Okay, let's look at different ways of using the find command. So firstly, we can say find, let's say we are just finding here, right where we are. Find, okay. If you are finding in the present working directory, okay, you can use dots, okay. You can use dots and specify type, dash type, right? Find within present working directory, dash type, and save F. F indicates file, okay? F indicates file, okay? If you do this, you can see these are the different files that we have in the present working directory. But the truth is, when we checked a list earlier, we didn't see as many as all of these that are specified, right? We only saw 2 files and 1 directory, right? We only saw 2 files and 1 directory. So what this means is that within this directory, there are some other files that are hidden, okay? If we had run ls-a, right? See, ls-a, you realize that all these other files that are showing up, we are also able to see them. You can see all of these files. Even files that appear in the subdirectory are also showing up. You can see the files in this directory, as well as the files in their respective subdirectories. You can see inside SSH here, there's a file called authorized key, right? You can see there's a file called authorized key, and you're able to see that here, right? You can see authorized keys, right? So what it means is that if we open inside here, you see a file called authorized key. So what this command has done is that this command has looked at the present working directory. If you remember, when we were explaining dots, we said dots could mean present working directory. I don't know if you noted it here, but it should be in the flashcards that I generated, right? We've gone through the flashcard, you see dot means present working directory, where you are, right? So I'm saying search within here, right? Find within here any file type, right? Any file type. Find, okay? Within here, any file type, okay? So we can also say we want to find any file that is empty, okay? Within this location. All we need to do for that is that we just specify empty. Okay, let's see. There is no empty file. Okay, so that is why it is not returning anything. Okay, so but usually to use this find command, okay, but before we proceed, okay, remember we ran this at first. We are finding within here type file, right? We can also specify that we are looking for directories within here, right? Remember, we have feb class, we have .ssh as directory. So if we run this right now, if we run this, we'll see that If you run this, it should display all the directories we have. You can see displayed directories we have, right? SSH, you can see Feb class, you can see. So it has displayed the directories that we have. So these are ways we can use the find command, okay? Just as we've used this up here, we should also note that instead of this, we can also use this sign, this tilde sign that we find beside to indicate find within the user home directory, okay? You can also use this, you can see it's giving us everything we have, right? And it's specifying the absolute parts, right? You can see this is the absolute parts. So we talked about the absolute part and the relative part during the last session. The absolute part, where like you are at the door saying, oh, you need to enter that room. Inside that room, you see under the table, you pick the top drawer, you see a file in there. Compared to while you are sitting in front of the table, you can just open the drawer and pick up something in there, right? One is relative, the other one is absolute. Like describing it from the door, right, is absolute. You can see /home /ec2 /.ssh, right? This is the directory name, okay? So just as we're able to use this, you're also able to specify file type, okay? But usually, when you are searching, you are not necessarily searching within where you are. The reason why you want to use the search command, the find command, is that you are trying to look for something and you don't know where it could be, right? When you start to run with different tools, you then appreciate why we are trying to get a grasp of this find command because we'll use it a lot, right? There is no time I don't use the find command, right? Because I don't want to overload my head with too many details, right? Oh, this file should be inside here, it should be there. I don't want to bother my head with all of those details, right? Rather, I can use find command, okay? If I use find command, I can say find within root. Let me clear so we can have a clearer screen, right? Clear. I can say find within roots, okay? That's everywhere. This is what you typically want to use almost always, okay? Find within root because you want to find everywhere. I know that the one we did earlier, we're finding in the present working directory, we're finding in the user home. We had just few files and few directories, so we knew where they are. But why would you use the find command? You use the find command because you are not sure of where the file or the directory could be. It could be anywhere, right? So you want to use the find command to look for it, right? So you are finding within root. Remember, the root is the parent of all directories. See, the root directory. Inside root, you find /home. Inside /home, you find /ec2 user, right? /ec2 user, right? Inside /bin, you find all sorts, right? All sorts of binaries, right? Inside here, you find all of systems binary. Inside here, you find configuration files, right? Find configuration files. So there's a file I want to look for. And the file is sshd_config. I know where the file is. I know it's somewhere inside the etc directory. But let's say I do not know, right? Let's say I do not know where it is, right? But I know where it is, but let's assume we do not know. That is why we need to use the find command, okay? Use the find command to look for it, okay? So I'm using the find command. I want to find within roots, right? Find within roots a file with the name or a directory with the name, that's -name. I'm searching with name this time around. Not unlike the other time where we were searching with type, whether it's file or directory. But now I'm trying to be specific. I'm looking for a file with the name sshd underscore config, right? I know what I'm looking for, but I don't know where it is. But I actually know where it is. It's in the etc/etc directory. But I'm taking it that I don't know where it is. Okay, so I do my find. You can see it's saying permission denied. Why will permission not be denied? Am I not? Am I running as root? No, that file, right, is a root file. Okay, and can only be accessed by a root user. But now I'm just EC2 user. But the good news is I have elevated privilege. So anytime we are finding within roots, you should always use sudo, right? Sudo, okay? Sudo will open the door to where you couldn't enter before, okay? So I'm running with sudo, you see the story is going to change. Tells me where it is, right? You see, straight to the point. Tells me it is in /etc, and inside /etc, there's a directory called SSH. Then inside that directory called SSH, there is a file called sshd underscore config. Okay, so it will provide an absolute path to where the file is. Okay, so there are several ways we can search. Okay, we can search by using name, right, as we've seen. We can search by using type, right, whether it's a file or directory. Okay, then we can even further specify empty, right, if it is empty, -empty flag. Okay, then aside that, we can also search using permissions. Okay, we can search using permissions. Okay, so there are different ways we can search, but we won't look at permission right now because we've actually not seen what permissions are. Okay, we've not seen what permissions are, but maybe this is an opportunity to look at what permissions are. So let's take a look at permissions. Let's see. Permissions, Linux permissions. Let's see whether I can see an image that we can use. Linux permissions. Okay, let's see images. Let's see if there are permissions. Okay, this is good. Okay, we can use this permission. Okay, so we can use this to explain what permissions are. Let's pick this image. Okay, I see this image. Let's see permissions. We are more concerned about the image. Okay, so this is the image. Okay, now looking at this image, you can see something here, right? This something is something we've come across in the course of our studies, but probably we didn't pay attention to it, okay? But now we'll see what permissions are and understand how these permissions work, okay? Now, if you look at this, you see that we have dash, okay? Then you have RWX, okay? All underlined together and classified as one. Then you have another RWX, all classified as one. And you have another RWX, all classified as one. So this depicts something, okay? This depicts file type, okay? The first one, this first one, which is dash here, it could also be underscore, okay? It could also be D, sorry. This dash could also be D. When it's shown as D, it means that it is a directory. Whereas when it shows as dash, it means it is a regular file, okay? Now, RWX that you have here, the first three, okay, which could be R dash dash, right? Or R something something, RWX. This R indicates read, W indicates write, and X indicates execute, okay? But this first set of trees, right? These first three components relate to that of the file owner, permissions of the file owner. Then the next three indicates the permission of the group owner, okay? Or for the group of the owner of the file, okay? Whereas this last one indicates the permission for all other users, okay? Now, let's take a look at something. Let's go back to our Linux, okay? Remember, this is where we are, ls. Let's clear this so we can have a clearer view, okay? If we do ls, you see that there's a directory here because we created it, and I know it. This is a directory. We created it in the last session. And these are files, okay? How do you know that this is a file and this is a directory? So for directory, sometimes it's the color that gives it away, and file is just blank, right? Bland, as it is. But there is a particular way we can ascertain whether it is actually a file or directory, because it will be stated. So if we do ls-l, we want to do a long list. You see, when we did a long list, you see that we have D, this starts with D, indicating it's a directory. You see, before we were able to say it's a directory because we created it. We knew we created it in the last session. But now we've been able to ascertain that this is a directory just by seeing this D, okay, preceding the permissions. So this D preceding the permissions shows that it is a directory, okay? This shows that it is a directory. So another thing we can look at is this. The next one is a file, right? Remember, we created a file, okay? So this next one that is a file, how do you know that is a file? You can see this dash, this first component here, the dash that starts it. When you see dash, it shows that it's a regular file, okay? We'll get to see some other options as we proceed, but let's keep it as simple as possible. So now, going back to this image, it says the first tree represents the permission of the file owner. The next tree represents the permission of the group. And the last tree represents the permission of others. Okay, now we've not started creating users, but I'll tell you this ahead, okay? When you create a user, for example, you create Lagbaja, by default, a group is created for Lagbaja, right? Which is the primary group. And that group name is also called Lagbaja, okay? So when you look at this structure, you see this, okay? You see this. This first component you see here is the owner. That's the user. The next one you see here is the group, okay? And a group could also be a secondary group, okay? We'll get to see all of this as we progress. But let's just keep it as simple as possible, okay? This is the user or the owner. The next one is the group. So any other person other than this owner or group is other, okay? So now let's count. 1, 2, 3, okay? This is read, write, execute. This read, write, execute belongs to the owner. Then the next one is read, dash, execute. It means that when you say dash, it means it does not have the right permission. It's just read and execute, okay? So read dash execute is for the group, whereas read dash execute is for every other person. okay? So now, you see this read is indicated by, okay, let's copy this so we can show some things, okay, in the notes, okay? So copy that. Let's show permissions, okay? Because it's important to understand permissions so we can permissions. So, okay, I'm to try to understand permissions, okay? So these are permissions, okay? Let's just say this permissions, okay? So we've seen that this first one is directory, and this one indicates it's a file, regular file. Okay, so if you look at the first tree, you see read, write, execute. Okay, so all of these read, write, execute are usually represented by numbers. Okay, so when you see read, read is represented by a number, and that number is 4. Okay, read is represented by 4. Okay, write is W. Okay, write means you can edit it, you can modify it. Okay, read means you can just see the content, like cut a file, but can you modify it? Can you edit the file? Okay, so write gives you the power to edit. Okay, and something called X means execute. Execute carries 1 as the number. Okay, so we have read, write, execute. Okay, so if, for instance, looking at this one that we have here that has read, write, execute, remember we need to classify them 3 by 3, right? 3 by 3. Okay, 3 by 3, we need to classify them into 3. Let me space, okay, so we can have a better view. Okay, space, you can see. Let's paste this as well so we can have a better understanding. And this, okay? You can see we specified that, okay? So this as well, okay? Okay, and we do this. Okay, you see, this first tree is for the owner, the next tree is for the group, and the last tree is for others, other than the owner and the group, okay? So, and we said R indicates read, W indicates write, and X indicates execute, and they are all represented by these numbers, okay? So how do these numbers work? So for this one, for example, all we need to do is to assign numbers 4, 2, 1. But in assigning numbers, we need to add, okay? This one has R, which is 4. This one has W, which is 2, and this one has X, which is 1. So to get the permission for this line, for example, let's copy this out, okay? Get the permission for that line. We are looking at 4 plus 2 plus 1, right? Okay. Okay. So here it is going to be 4 read, okay, plus dash is 0, okay, because it's nothing, plus execute is 1, okay. So the last 3, okay, is also 4 for read. There's nothing for write, so it's 0. And execute is 1, okay? So looking at what we have up here, we can say 4 plus 2 plus 1 is 7, okay? 4 plus 0 plus 1 is 5. And 4 plus 0 plus 1 is 5. Okay, so we have a 755 permission. So for this, looking at it, is a 755 permission. Okay, 755 permission. But for the next one, which is a file, okay, you can say read, okay, you can see this is a 755 permission. 755 permission, okay? So this is a 755 permission. We'll get to see how this works as we proceed in this program, okay? That's a 755 permission, okay? So let's say we are copying something else, okay? Let's say we are copying this, okay? Okay, let's say we are copying this and do the same thing by this, okay? So we are copying that and doing the same thing, okay? So, okay, let's copy that, okay? So we've copied something else. We've copied what we have here, okay? The next line, right? So for this, we can do the same thing as we've done above, okay? Read is 4 plus write is 2 plus execute is non-existent, so it's 0. There's space that. The next one is read, just 4. Write is not existing, and execute is also non-existent. Okay, so then the final one, 4 is read. Write is 0 because it's non-existent, because it's a dash, and execute is also non-existent. So here we can say we have 4 plus 2 plus 0, 6. Okay, here you can say you have 4 plus 0, 4. And here you can also say you have 4. Okay, so for this file, it's a 644 permission, right? Permission. You see, we have a 644 permission. So why do we have a 755 permission? Did we set it up? Okay, did we set it up? We did not. It's by default. Okay, that is by default. Okay, so the default permission for a directory, okay, is 755 permission. A default permission for a directory in for a regular user. Okay, let's put it that way. For a regular user, the default permission for a file is 755 permission. Okay, and for a directory it's 755, but for a file is 644 permission, right? You see, we didn't set any permission while creating this account, right? So now, before we proceed, is this going to be the same kind of permission if we are looking at a root user? Okay, so let's see, this file was created by a regular user, it's 644. And this directory was created by a regular user, is 755. Let's take a look at roots, okay? Let's see roots, okay? So here we are, okay? This is user home directory, and these directories, you can see, they belong to the roots, they belong to EC2-user, sorry about that. So if we want to see roots, okay, let's go to root, for example, cd to root, ls, okay? So let's go to etc directory, cd to /etc, but because it's relative path, we are here, so we can just use relative, okay? So you can see all of this, okay? So if I do ls-l, I want us to take a look at something, okay? Obviously, this is a directory, D, okay? This is a directory, and this is a file, okay? You can see, it starts with dash, right? Starts with dash, okay? So this is a directory, this is a file, okay? So let's copy this, for example, okay? Let's copy this, okay? Or what we can do, let's create, okay? Let's create something, okay? Yeah, let's create something. Let's say we want to create, because some of these, their permissions have changed, so we will not be misguided, okay? Let's say we are creating a file. Remember, to create a file, we use the touch command, okay? Let's just use touch command, okay? Touch, okay? Let's say, let's just call this test file. Let's just call it ensure.txt, because this is the etc directory. We want to be careful of what we put there, so I don't mix things up. Ensure.txt, okay? Permission denied. Why is permission denied? Because I'm trying to create something in the root directory. But how do we bypass this? By introducing sudo, okay? You can see I created that, sudo. So if I also go ahead and make a directory, say sudo mkdir, right? I call this ensure as well. Okay, I'm creating a directory. I call it ensure. Okay, if I ls right now, ls-l, okay, let's scroll gently to h. Okay, let's see what we've created. You can see we've created some directories here. Okay, we've created some directory. We've created a directory. We've also created a file. Okay, we've created a directory and we've also created a file. You can see what we have here. The ownership is root, right? You can see the ownership is root because of where we created it. Okay, the ownership is root and the group is also root. Okay, so this is just to demonstrate this. Okay, this is to demonstrate ownership of files, right? You can see ownership of files and ownership of directories. Okay, so let's see what happens if we go ahead and let's see what happens if we decide to sudo, okay, sudo su, right? We want to switch to root, okay? So we've switched to root now. Let's touch a file, okay? Let's go back to, where are we? Okay, we are in, okay, let's go to etc, the same etc, okay, let's go to etc, cd, okay, slash etc, okay, cd slash etc, okay, ls, remember, this is where we were, we created ensure, where is it, h, right, we created these two here, okay, so I want to create additional file and directory, let's say touch ensure2 2.txt, okay, touch. Then we also want to make a directory, okay, mk, okay, mkdir ensure2, okay. So if you noticed, we were able to create these directories here without using sudo, okay? And the reason being is that this that we've just done was done by root. You can see we are logged in as root, okay? So not as EC2-user, okay? We have logged in as root, okay? So if I do ls-l, right, and scroll up, okay, let's scroll up to ensure, okay, let's scroll up to ensure. You can see this is also created and we have root, okay? It's also created as root, okay? So this is something I just want us to establish, okay? So just as we've done in the past, okay? Just as we've done in the past, let's just copy this to see what we created as root, ensure. We created this, okay? You can see there's no difference between what we got, okay? So let's just copy this and come in here, okay? Let's come in here and paste this, okay? You can see what we've created, okay? Okay, so these ones were created in the as root, right? It required elevated privilege to create, okay? Unlike those other ones, because of their location, we're able to create them as we've created them, okay? So now that we've done this, let's move further, okay? Let's move further and let's see how we can use permission, okay? How we can use permission to find a file, okay? How we can use permission to find a file, okay? So, but before we use permission to find a file, I think it's important, we'll come back to this, using permissions to find a file. It's important to even know how to change permissions, okay? So that we can be specific, okay? We want to see how we can change permissions, okay? So we can understand specifics, okay? So now that we've done this, so the next thing we want to do is to come back to the server. Let's exit, okay, from root and go back to normal user, okay? You can see we are back at EC2-user. I can enter CD to go home, okay? Now we are the home of EC2-user. You can see home of EC2-user, okay? So if you can confirm with pwd command, tells us we are the home of EC2-user, okay? So this is the home of EC2-user. Now that we've done this, so the next thing we want to do is that we've seen how we can create a file, right? Okay, the next thing we want to do is to see, okay, can we copy a file? Yes, it's also possible to copy a file, okay? But how do we do that? Okay. ls at the moment, you can see this is what we have. We have this, okay? Okay, if we run our tree command, you can see we have Linux, we have feb class, right? You have list, okay? So we can say we want to, you know, make a directory here. Let's quickly make a directory. Make a directory, mk dir. Let's make a directory and say let's say class 101, okay? This is a directory, class 101, okay? So we've made a directory. If we run the tree command right now, let's see what we see, okay? So now we want to copy a file, okay? We want to copy a file. To copy a file, it's also very simple. Copy, C-O-P-Y, okay? Copy, C-O-P-Y. So to copy a command, you need the CP command, okay? Copy, C-O-P. Why? Okay, cp command will help you to copy a file. Okay, so for example, you might say you want to copy a file, maybe linux.txt, for example, and copy it and put it inside class 101. Okay, you might say you want to copy this file and put inside a different location. Okay, now to copy a file, we say use the cp command. Okay, so if I do cp alone, is this sufficient? No. What am I copying? I need to specify what I'm copying. I'm copying linux.txt. Okay, so I specify that. Where am I copying this to? Okay, where am I copying this to? I'm copying it into a directory that is right here. You can see class 101 is the directory. Okay, I'm copying it into that directory. Okay, that is right there. So if I copy now,
Can I ask a question?
sure, sure.
Okay, I can remember last week we had something like SCP.
Yeah.
Why are we not using it?
Okay, good, good, good. So SCP is secure copy. Okay.
Right. Yeah.
Copy is like you are copying within the server.
Okay.
You understand? We are right
Right.
here.
Right.
But
Yeah.
if you have a server, your own server that you have over there, and I want to copy something from my server to your own server,
Okay.
these are different servers.
Right.
I
Right.
need to use the SCP
SCP.
command.
Okay.
And
Okay. Good.
SCP is more complicated because SCP will require password access. I need to have password to your account to be able to even
Okay.
use SCP.
Right.
Okay. So usually people use SCP to copy from one server of theirs to another server of theirs.
Okay. I got it
Otherwise,
now.
they'll use the key. Okay.
Right. Okay. All right. Thank you.
You're welcome. So this is CP. Okay. So I want to copy Linux from where it is, okay, and put it in class 101. Okay, so I say CP, okay, CP what? What am I copying? Linux.txt. Where am I copying it into? I'm copying it into class 101. Okay, so if I do this, it's copied, right? Because I do not get any error. This is a good sign. When you run a command and it just returns as it is, it shows that everything is working well. So if you remember, when we ran our tree command earlier, what do we see? Class, which was empty, February class, empty. We had Linux and we have list. But when you say you copy, when you copy means it's just a duplicate, right? That you have just made. Okay, we just made a duplicate. So I still expect to see this my Linux, okay? And I expect to see a duplicate inside class 101. So let's run the tree command to see what it's looking like. You can see running the tree command shows us that linux.txt is found in class 101 as we have instructed. Yet we still have linux.txt, okay? But if, for example, we decide to say, see, remember this is what we did. We just say copy linux.txt and copy into the present working directory, like this location. You see, if you do this, it's saying this and this are the same file, right? Because it's just copying it exactly as it is. You can see, copied it this way and pasted it this way in a different place. But does that mean I can't copy something from this location to this location? I can actually do that, okay? But I must do that and make sure that they are not carrying the same name, okay? Okay, so if you remember, let's do our tree command again to be sure that we don't have a duplicate, right? You see, no duplicate has been created yet. But what if we want to have this linux.txt right here, right? We want to have a copy, right? want to call it maybe Linux 2 right here, but they'll have the same content, right? If you see at the moment, we cut that file, linux.txt, you can see the content, right? All of these beautiful things we put in, right? So let's clear, and run our tree command again. I like to see the tree, okay? You can see. So let's say I want to copy, right, into the same location. In that case, I won't use the same name. I need to create a different name. I can create any name I like. I can even decide to call it a different name entirely. I can say linux2.txt. I can even say linux-copy.txt, right? So I will know what we are testing, .txt. Okay, this is what I can do. But always remember, when you are creating a file or a directory, you must make sure that they are all tied together. Otherwise, a file called Linux and a different file called copy, right, will be generated. So as much as possible, keep them together, okay? So you can see cp this space this, okay? So if you do this, you can see we didn't get that error we got at first, okay? Because we've just created a copy. A copy has been created. And if you come here and look at tree, okay, you see that a copy has been created in the same location. But if you want to create a copy in a different location, you don't have to change the name, okay? But if you want to create it in the same location, the name needs to change, okay? The name needs to change, okay? So now, what if we want to copy a directory? Let's say we want to copy a directory. Remember this directory, okay? Let's say we want to move Feb class inside this directory, just as we did for this Linux, okay? Is it possible? Yes. But can we just use cp command? Let's say cp feb class, okay? Feb class, and we say want to move it into class 101, okay? If we do this, will it work? No, we are going to encounter an error, okay? See, it says R not specified, okay? So what it means is that if you are copying a directory, you don't just stop at cp. You need to put the -r flag. cp -r feb class, okay, to class 101. You are copying this to this location. But unlike a file that you can just use cp alone, right? But for directory, you need to specify the -r flag, okay? You need to specify the -r flag. And that is what we are going to do, okay? So if we do this now, are we going to get an error? No, okay? So you can see it went straight where we want it to be. So Feb class is in here as well. But what if we want to create a directory, make a copy of this directory exactly where we are, right? Want to make a copy of this directory exactly where we are. How do we go about it? Okay. To go about it, all we need to do is to do exactly the same thing we did earlier, right? What we did earlier with the file, right? What we did was to ensure we give it a different name, okay? So if we want it in this location, this exact location, we can just come and say feb class dash copy, right? This is something we can do, okay? It could be feb class 2 or feb class whatever, or lagbaja or tamet or whatever it is we want to call it, okay? But the reason why I'm using this copy is for us to understand that this is actually a copy of that, okay? So I say this, okay? So once I do this and I run my tree command again, you can see we have a copy created here, okay? So you can see how we use the copy command, okay? Now understanding how we can use the copy command will make it easier when we want to use the SCP command, okay? We'll just look at the different other variables that pertains to server transfer, okay? So we'll be using the SCP command a lot, okay? But this is how we start. You see, CP to copy a file, CP-R flag will copy a directory. Now, let us say, remember with our, what's it called? What's this called? With our windows, you can copy, right? I can right click, right? You can see I can copy, I can show more options, I can copy, you see. I can also cut, right? Like when I use the cut option, I'm taking it out, right? Like moving it, like cut it out of here and go and paste somewhere else, right? I can cut from here, for example. I can cut. See, I've cut this. Let's say I want to put it in here. I can cut and paste in here, right? Let's see. This is with Windows, right? I can paste. You can see. Source files and destinations are not the same. Okay, let me cancel this. Let me not mess up my my pen file. Let me use this one instead. Okay, so I cut this logo. Okay, if I cut this logo, here's the cut option. Right click, show more options. I cut. Okay, and I come in here to paste. Right, even without going in, I can paste from outside. Okay, you can see it's gone. It's gone from here, right? But where is it now? It's somewhere else, right? It's somewhere else in here, okay? It's somewhere else in here. This is where it is, okay? This is where I've pasted it. So you can also come here and modify, right? By right-clicking, okay? I can rename, I can modify a directory, I can modify a file, I can rename, right? And see, can rename this and say miscellaneous. Right? I've renamed, okay? So I can do all of these good things with Windows, okay? So just as I can do all these things with Windows, I'm also able to do them using my Linux, okay? Remember, I created this copy, okay? I can say, oh, I want to move this from here, okay? I want to move list this time around. You can see this list. I want to move it from here and move it into, or alternatively, let me move this one that is a copy, okay? So I will appreciate what we are doing, okay? I want to move this file that is a copy that is here, okay? I want to move it into here, okay? I want to move it into class 101. So to move, you use the MV command, okay? MV, copy, you use CP command. To move, you use MV command, okay? So I can come here and move this, okay? And say MV, what's that file name? Is Linux, let's paste it. Linux.copy.txt. Remember, this is case sensitive, okay? So if you mistakenly type uppercase L here, it won't see it because it's not the same, okay? So you come here and you use the move command. Where are you moving to? You are moving to class 101, right? You are moving to class 101, okay? So you are moving to class 101. So if you click on enter now, let's see. Let's run our tree command. you can see this file that was out here is no longer out here. Just the same way, the logo that I had out here found its way into here, into Miss, right? So also we've done, right? So we've been able to depict the same example right here. Okay, let us even say, just as we renamed that file from that directory from Miss to miscellaneous in full, can we also modify this? Okay, we can also do the same, right? We can change the name of this from what it is right now using the mv command. So the mv command can be used to either relocate a file or even a directory, or rename a file or a directory. Exactly what cut did for us on Windows, so also mv command is able to do the same for us here. Okay, so with mv command, remember, with mv, let's say class 101, and you want to change the name to class underscore 101, class underscore 101, okay? Let's say this is the name we want to change to. Remember, just as we copied the other time. But when we copied, right, we copied it, but the original remained, okay? But let's see what happens when we move or rename, okay? With renaming, original does not remain, it changes, okay? So that is the power of rename, okay? So we use mv command to rename, okay? So now you see right here is class 101, okay? Now that we've renamed it, I'm expecting it to be class underscore 101, okay? So let's go ahead and run the tree command. You can see running the tree command, this has now changed form, whereas every other thing that is in it remains, okay? So just as we are able to use the mv command, okay, you can see this is a directory, unlike copy, right? With copy, you needed the -r flag, right? But with mv, you don't need the -r flag. All you need to make it work is the mv command, right? So just as we moved this file, okay, we are also able to use the mv command to move a directory inside here, okay, inside class underscore 101, okay? So let's do that. mv, want to move what? Want to move this, copy. Let's paste this here. Want to move it to class underscore 101, okay? Let's move it to class underscore 101, right? This is where we are moving it to. So if you run the mv command and move it to, use it to move the third class dash copy to class underscore 101, we'll see that here there will no longer be this here because we are cutting it, like cutting and pasting elsewhere. Okay, that's what the move command does. It either cuts and pastes, like moving, as the name suggests, or renames. Okay, so the mv command does not require the -r flag. Okay, unlike the cp command. Okay, so you can see this is a success. So if you run the tree command, let's see what we see. Can see this and this are now in here, okay? So you can see how the forms are changing. So what we need is an understanding, okay? An understanding of what we are doing, okay? So let me quickly touch a file, okay? Let's touch a file. Okay, instead of touching a file, let's just go ahead and run a command. We've seen mv command, okay? So if we say file, okay? File as it is a command as it is, file, okay? File is a command. File is used to display the type of a file based on its contents, okay? For example, let's even say we know this is a text file, right? But let's say we decide to rename it and not specify what it is. MV list, okay? List, okay? Dot txt, right? We want to just call it list, okay? We also want to call it list, okay? So if we come here and run our tree command, you see that this file name has changed to list, okay? But if we want to check the type of file it is, okay, can say file list, okay? It tells us it's a text file. How does it even know it's a text file, right? Because of the contents, right? We put in some names, Ade, Mola, Edward, we put in some names, okay? So it's telling us that it's a text file, okay? So let's see what happens with this other one, linux.txt, right? Let's see. It also tells us it's a text file, right? The reason why I took out the txt from this, so that we won't just conclude that, oh, we already told it what is the name of the file is now. We said it's txt. That's how we got to know it's txt, right? You can see. So let's say we mistakenly say file, and we decide to say feb class, right? We know that that's not a file. You can see, it tells us it's a directory, okay? So with this file command, we are able to know what a file is, okay? File could be a text file, or in this case, it could also indicate what it is, that it is a directory, okay? So you can see what the file command does, okay? So the best way you can get this is on your own. Just try to navigate all sorts, try to play with all these commands, okay? Not necessarily by following what I've done, okay? But by exploring, like digging deeper, trying to understand some things, even things I've not taught, okay? Test things out. It doesn't hurt. Even if something goes wrong with your server, you can always terminate it and create another one, okay? So the way we terminated the server just now and created and used the existing one. So you can always terminate. Don't be afraid to explore, okay? So this is just a server for test, right? At work, you not have the opportunity to experiment with company server. But right now, this is your server. You can do anything you like with it. There's no company's data on it, right? So I just want you to always bear that in mind, okay? So I want you to bear that in mind. So there's something else we can do to a file. Remember, we said we could cut a file, right? We're able to cut list.txt, which is now list, right? We're able to cut this file to see the contents, okay? So there's a command called WC word count, okay? Word count. So WC command will display the lines, words, and characters of a specified file, okay? So if I just say WC, how would the system understand what we want, okay? So most of the times when you hear these commands, okay, depending on the situation, you need to use it with something else, okay? WC what? WC list, right? I want to see the word count for list, okay? So when you do this, okay, it tells me there are 5 lines, right? Tells me that there are 5 lines, tells me that there are 5 words, and it tells me that there are 24 characters, okay? 5 lines, line 1, line 2, line 3, line 4, and line 5. How many words? 5 words. Ade, Mola, Ola, Ed, and Ensure. And how many characters? 3, 7, 10, 12, 13, 14, 15, 16, 17, 18, 19. What's missing? 24 characters. 3, 7, okay. Okay. There are some spaces, right? Which if we VI into this file, let's see, just to confirm, VI into that file, VI into that file. Okay, we counted 19, list. Okay, we'll see that there are some characters, although they are not displayed. List. Okay, you can see maybe there are white spaces across. 24 characters. Okay, so list 5 lines, 24. Okay, I'm sure there are some white spaces when we're typing the names. There were some white spaces. Okay, so it shows that there are 24 characters. Okay, so not necessarily words, but could be white spaces in between the characters. Okay, could be white spaces, WQ. Okay, white spaces in between the character, in between each character. Okay, so we have 24 characters. So this is what this does. Okay, so but it is also possible that we want to get just some components. Okay, remember we saw this as lines, we saw this as words, we saw this as characters, right? So we can say we want just the words. Okay, to get just the words, can use the WC dash. We want to get just the lines. Okay, lines, because it gives us 5 lists. Okay, 5 lines. Okay, if you come here and you say word, okay, words, it also tells us is 5. Okay, if you come here and you decide to use the character flag, okay, you see it tells us 24. Okay, so you might be looking at it and say, oh, it's because this is not big, right? The data are small and all of that. But let's see what happens when we have larger data, right? So remember the other file that we created, linux.txt. Linux.txt tells us that we have 78 lines, 270 words, and 1,701 characters. Okay, so just the same way, we can also check for lines alone. Want to see lines, wanted to display lines alone for us. You can see, it tells us there are 78 lines. You can see the consistency. Look at the words, tells us that there are 270 words, right? I also want to check characters, including white spaces. It tells us we have 1,701 characters. Okay, so this is how we check this. Okay, so now there's also something very important. Okay, there's also something very important, especially as we proceed in this program, we'll get to understand why we are actually looking at it. Okay, so we've looked at this. Okay, so the next thing I want us to look at is to look at creation of links. Okay, links. Okay, links. Okay, so there are 2 kinds of links. Okay, there's the hard link and there's the soft link. Let's put a small note here. Okay, so I say links. Links. There could be hard links links, and there are also soft links, okay? Soft links. So there are hard links and there are also soft links, okay? There are hard links and there are also soft links. Okay, so what are hard links and what are soft links? So before we go further, let's take a look at something. Remember, when we created all of this, let's clear the screen. When we created some files and directories, we did ls-l. We're able to see, oh, this is a file, this is a directory. And sometimes we look at the color, it gives it out, right? Tells us what it is, right? So just as we have this, we can also create links, okay? So now, when you create a link, I think it's best we just create a link. That way we can explain it to see what it is, okay? So let's see how we can create a link, okay? Let's look at the files we have. We have list, okay? We have list, okay? We also have linux.txt. But to make it easy, okay, let's just use list, okay? It's shorter. So I like to go the easy way. Okay, so to create a list, what command do we use? Okay, to create a list, we create a list using the command link. Okay, to create a link, use the command link. Okay, the command to create a link is going to be ln. Okay, so remember to move, move, we used the move command, right? To copy, copy, we use the copy command. To create links, you use the ln command, okay? Like clicking the first and the third character, right? So that's just, by the way, it doesn't always work that way, but this helps. See, list, right? L-I-S-T, L-S, right? So you can see to make a list, you see, ls. So this way, we're able to look at a command and figure out, okay, this is what it is, right? No stress on the brain, you know. Let's keep our brain light, no much load, okay? So what we want to do is to create a link. So to create a link, let's say we want to create a link for this file called list, okay? So to create a link, you say ln list, okay? So if you say ln list, okay, so what name do you want to call it? You know, just like when we copy and you're copying within the same location, you know, you can specify a name you want to call it, or if you want to even copy it outside, you want to take it outside, you can even specify a path and a name, okay? So for this, let's say we want to call it add link, right? So because when you want to create the add link, you don't specify any flag, okay? Just say ln list, then let's just call this list, right? But this time is add. I'm just putting this so I will know what it is, okay? List, list add, okay? The name could be anything. It doesn't have to be specified like this, okay? I'm just specifying it this way so that when you are going through the video again, you understand, okay, list, okay, link, okay, to create an add link, okay, okay, we used just this without specifying a flag, okay? So when I run this, I see that if I check ls-l, I see that a new file has been created, okay? So looking at this new file, I look at it, it's like exact, it's just as if I copied, right? Just as if I use the copy command, because nothing is looking different, right? Look at it. Content 24, right? This is the size. Content 24. You can see even the date and time, right? You see, everything is the same. It's just as if I copied this, right? Nothing has changed, right? So that is add list, add link, okay? Add link. So if I go ahead and say, I want to create a soft link, although it might look, you might be wondering, what's this supposed to mean? What's the whole essence of add link, soft link, and all of that, okay? But let's follow as we proceed, okay? So when you want to create a soft link, okay, you use the same command, okay? But this time around, this is the name, okay? But this is not where the difference is. You need to specify a flag, a -s flag, indicating soft link is what we are trying to create. Disregard, this name could be anything, okay? I just put it there so I will know what we've created, okay? So if you remember, this is exactly the same, except for the name, okay? Without the name, it would have been difficult for us to know that, oh, this is the link, right? It's just as if we copied, right? But now, when we create a soft link, let's see how it behaves. When we do ls-l, what's happened, okay? So the first thing that we should notice is that, unlike this, that the file name is specified as dash, here it's showing us that it's link, okay? It's showing us that it's a link, right? So you also see that this shows that it's been used twice. You can see that you have two of these, right? That you have a link, okay? Then you also go ahead to look at the size. You can see this is much smaller, okay? This is much smaller. And look at this. It shows that this link, this is linking to this, okay? So what this means is that if for some reason I come into this file, right? Let's say I come into this file, let's cut this file, list, okay? Let's see what happens. Ade, Mola, Ola, Ed, and Ensure, right? Let's cut another file, cut add, right? Let's cut add, okay? You can see that as well. You're able to cut that. Let's see what happens. We try to cut list, right? You can see we are using the cut to check the components, okay? You see, everything is the same, right? But let's see what happens. If we go to this list, for example, this list, and we go to list, vi into list, okay? Vi into list, the original list, and we decide to add king to this list. King, okay? Let's save it. Want to see how links work, okay? Decide to add link, king to this, escape, column, WQ, okay? I've saved this file, okay? So if I decide to cut list again, you see what we have there, there's king. If I decide to cut the add, you can see I have king. And if I decide to cut soft, okay, you see I have king, okay? But does this also happen to a file that I've copied? No, because the file that I've copied, let's see, ls-l, okay? You can see all of this has changed, the size of this has changed, the size of this has changed, whereas the size of this didn't change because it's linking to this, okay? So what happens is that, you see, we are seeing the relationship, okay? So if we run our tree command, let's see what happens when we run our tree command, okay? Tree, right? Run our tree command, you see, there are several other files that we made out of this. If we decide to go and cut any of those files, let's say cat, the file is in class 101, right? And let's say we want to cat within copy list, okay? Within copy list, so we can't use that as an example. But you can see how links work, okay? If it was just copy, you won't see that the change you made in the original file is affecting the next one, okay? Because it is copy, okay? You have a copy, you have a duplicate. But for link, anything you are doing to the main one is affecting the other file, okay? So what happens is this. How is this now different, right? We have two, right? So what happens is, if I now go ahead and delete rm, right? What file? I want to delete this file, list, okay? If I delete this file, you see, rm, I've deleted it. If I do my ls-l now, -l, take a look at this part. See what it's looking like. This, right? You can see 29, 29, 4. You can see, okay? So if you do ls-l, what did you notice, right? List is gone. However, I'm still able to cat list add, list-add, add, right? Can see list-add. I still have the content. Whereas the main file has been deleted. The list file has been deleted. Whereas I'm still able to get access to the add link, right? Because it's carrying the old file exactly as it is, okay? However, what happens if I try to cut the soft, okay? Because the soft is lightweight and is linking to something that no longer exists. You can see the color has changed, okay? It's linking to something that no longer exists. Let's see, you can see no such file or directory, okay? With this, I think is a perfect time to bring the class to a halt, and let's go through what we've done so far. In tomorrow's session, we are going to continue from here and look at more Linux commands, okay? We'll get to use these Linux commands all through the program, so an understanding of it is very important. Okay, do we have questions?
Not for now.
Oh, great. So,
Yeah.
thank you very much. So, let's have a wonderful night and prepare
Thank you.
for the next session. So, tomorrow is going to be more exciting.
That's right. Thank you.
Thank you. Bye for now.
Bye.